Hey guys, welcome back to the Carrot Tutoring YouTube channel. My name is Stanley and I am a tutor from Carrot Tutoring. So today, I'll be covering how to find horizontal and vertical asymptotes of a function. In this video, it will be super short and cut to the chase. So let's get started. So let's get started with understanding how to find the vertical asymptote. So to recap, an asymptote in its simplest definition is a straight line. Let me represent it with a dotted line, and let's choose the color green. I'll be putting it at x equals 3. So an asymptote is a straight line that a curve approaches as it heads towards infinity. So notice that the curve does not touch the line, but rather the curve is creeping closer and closer towards this asymptote, this vertical asymptote, to infinity. So if we were to be given a function, how do we find the asymptote? So let's use this example that I got from purplemath.com. So your function will be y equals x plus 3 over x squared minus 9. So for vertical asymptotes, we must look at the denominator. So go ahead and just ignore the numerator. I want you to just look at this function, this equation right here, x squared minus 9. What you would want to do right now is to equal that to 0. So x squared minus 9 equals 0. So isolate the variable, plus 9 on both sides. X squared equals 9. Take the square root. X equals positive or negative 3. So this means that your vertical asymptotes will either be at x equals 3 or x equals negative 3. So let's see that on a chart, a graph. Let me use the red marker. So these will be your asymptotes. But what about horizontal asymptotes? Well, horizontal asymptotes are a bit trickier because it involves both the numerator and the denominator. And you have to remember three rules for finding the horizontal asymptotes. But don't worry, they're super simple and I'll guide you through them. So the first horizontal asymptote rule is that if the degree of the numerator is smaller than the denominator of that particular function, then y equals 0. So your horizontal asymptote will be 0. The rule number 2 is if the degree of the numerator is equal to the degree of the denominator, then your horizontal asymptote will be the ratio of the leading coefficients of the numerator and denominator. Rule number 3 is if the degree of the numerator is bigger than the degree of the denominator, then the horizontal asymptote will not exist. So meaning it will be unbound. So let's take a look at 3 examples in order to understand horizontal asymptotes better. So take a look at the function h of x equaling x over x squared minus 4. Yeah, let's do that. So in order to find the horizontal asymptote, we need to determine both the degrees of the numerator and the denominator. And if you don't remember, in order to find a degree, you need to take a look at the variable, so the x, and determine its exponent. So the exponent for the variable x would just be 1. And then let's take a look at the denominator. So we have one variable, x squared. So therefore, the degree of the denominator would be 2. So it'll be 1 over 2. So because the degree of the numerator is smaller than the denominator, your horizontal asymptote will be y equals 0. So super simple. Let's take a look at the second example. Let's take a look at a second example. So d of x equals 4x squared over 5x squared minus x. So let's take a look at the numerator first. So we have 4x squared. As you can see, the only exponent we have is 2, which is going along with the variable. So therefore, the degree of the numerator is 2. Now let's take a look at the denominator. So as you can see, there are 2 terms in the denominator, but we only take a look at the first term because when we take the degree of something, we only look at the first term. So you can go ahead and cross this out. So ignore this person, this baby. All right. So as you can see, we have only one variable and one exponent, which is 2. So therefore, the degree measure is 2. And since they're both equal, we have to take a look now at the leading coefficients. So remember, the coefficient is the number in front of the variable. So it will be 4 and 5. So therefore, the horizontal asymptote will be y equals 4/5, or 0.8. Now let's take a look at a final example. So we have s of x equaling x squared plus 2x plus 1, all over x. So let's take a look at the numerator first. So we only look at the first term, so x squared. So that means the degree of the entire numerator would be 2. As for the denominator, the exponent for x would just be 1. So therefore, the degree of the denominator would be 1. Because 2 is bigger than 1, the numerator is greater than the denominator, that means the horizontal asymptote would not exist or unbounded.